Hi, welcome to your Mac 200 Statics online classes. Today we're going to continue working on Chapter 5 that talks about the equilibrium of a rigid body. In this third video, the aim is to extend the equilibrium analysis to three-dimensional problems. I hope you enjoyed this video. Just like we did when we solved two-dimensional equilibrium problems, the first step in solving three-dimensional problems is drawing the free body diagram. However, before we do this, it's first necessary to discuss the types of reactions that can occur at 3D supports. As in the two-dimensional case, a reaction force is developed by a support that restricts the translation of its attached member, and the reactive couple moment is developed when the rotation of the attached member is prevented. We can present here a list with the supports typically used to represent 3D structural members. Some of them are essentially the same ones we saw in the previous list, but viewed in three dimensions. The first type of support or connection is the cable connection, in which, just like in the 2D model, has only one unknown. That is the reaction force acting away from the member through the direction of the cable. The type 2 member is the smooth surface support, which, like in the 2D representation, has only one unknown. That is the reaction force acting perpendicular to the surface at the point of contact. The type 3 member is the roller connection, which, likewise the previous element, has only one unknown. That is the reaction force acting perpendicular to the surface at the point of contact. Then we have the type 4 element, which is the ball and socket connection element, which has three reaction forces as unknowns, one in each direction of the 3D coordinate axis, resulted from the restriction to translation in these three directions. Next, we have the type 4 element, which is the single journal bearing support, widely used in rotating machines. In this type of support, the shaft is prevented to translate in the X and Z directions shown in the figure, which creates the two reaction forces Fx and Fz. The shaft is also prevented to rotate about the X and Z axis, which generates a reaction moment about the x-axis mx and another reaction moment about the z-axis mz. The type 6 element is the single journal bearing with a square shaft. In terms of reaction forces and couple moments, this support is very similar to the previous single journal bearing one. However, it adds a reactive couple moment in the y direction, my, because it also prevents the shaft of rotating about the y-axis. The next type of bearing support is the single thrust bearing, which is also similar to the single journal bearing element in terms of reactive forces and moments, but it adds a reactive force in the y direction, Fy, due to the restriction imposed to the shaft to translate across the y-axis. The next type of support is the single smooth pin, which for the representation in three dimensions will have three reaction forces, each one along the three axes, Fx, Fy, and Fz, due to the restriction to translation caused by the pin, and two reactive couple moments, one about the y direction, My, and another one about the z direction, Mz. Those reactive moments appear because the bar is not allowed to rotate about the y and z directions. Then we have the single hinge support, which also creates three reaction forces, Fx, Fy, and Fz, due to the restriction to translation, one reactive moment about the x direction, Mx, and one reactive moment about the z direction, Mz, due to the restriction to rotation about this axis. The last type of connection is the fixed support, which is the most restrictive one and will generate in total 6 reactions. 3 forces due to the restriction to translation along the x, y, and z axis, and 3 couple moments due to the restriction to rotation about the x, y, and z axis. Some real-life examples of these supports can be presented here, like this ball and socket joint that provides a connection for the housing of an earth grader to its frame. We have this journal bearing connection that is used to support the ends of a shaft. We also have this thrust bearing that is used to support the drive shaft on a machine. And we also have this pin connection used to support the end of the strut used in a tractor. Now, let's work on some examples. In example 5.14, we have this structure here in which external loads are applied as shown in the figure. We are then requested to draw its free body diagram. Following the same procedure outlined for 2D equilibrium problems, we start by isolating the structure from its connections, sketching a simple outline of its shape, and placing the coordinate system axis. With that, we are ready to identify the forces and couple moments acting on the structure, starting with the downwards 500 newtons load aligned with the z-axis applied at that specific location, and the 45 newton meters couple moment oriented towards the positive x direction applied at this section of the structure. Following the procedure, the next step is to show the reaction forces in each one of the single journal bearings located at A, B, and C. Starting with the bearing at A, we have 2 reaction forces acting along the y and z axis, AY and AZ, which are generated because of the imposed restriction to translation of the shaft in these directions. For the bearing at B, we have 2 reaction forces acting along the x and z axis, AX and AZ. And for the bearing at C, we have 2 reaction forces acting along the x and y axis, AX and AY. And with that, the free body diagram is done, because the force reactions developed by the bearings are sufficient for the equilibrium, since they prevent the shaft from rotating about each of the coordinate axes. Because of this condition, no couple moments at each bearing are developed. Now, let's draw the free body diagram for the second example here. Again, let's start by isolating the structure, sketching up its outline shape, and placing the coordinate system axis. Next, we move to the applied loads, in which we have the 300 pounds force aligned with the z-axis applied at the location indicated in the figure, and the 200 pounds foot couple moment oriented towards the positive y direction applied at this section of the structure. Now we are ready to identify the unknown reaction forces acting on the structure, starting with the tension force in the cable BC, the reaction forces at the pin connection at A along the 3 directions, AX, AY, AZ, and the reaction couple moments MAX and MAZ. The moment components are developed by the pin on the rod to prevent rotation about the X and Z axis. The free body diagram is now ready to be used to develop the equations of equilibrium. And with that, we have finished part C of chapter 5. Thanks for watching, and I'll see you in the next video.